All right, so today's lesson focuses on factoring algebraic expressions, so factoring monomials and polynomials. Remember that word mono, prefix mono means one, poly means more than one. So let's just quickly review what is a monomial. All right, so if I just started off with an expression x, that is a monomial. Okay, if I add a squared to it, still a monomial. If I add a coefficient to it, still a monomial. If I add a negative, still a monomial. I can add more variables, and this is still a monomial. What changes an algebraic term from a monomial to a polynomial is multiple addition or subtraction signs. So as soon as I put an addition sign, right, so plus 2, that is now a binomial because there are two terms, right? Negative 3x squared, y cubed, z squared, and then a positive 2. And then I could add plus 3xy. That is now a trinomial, 3 terms. So remember, we sort whether it's a monomial, binomial, trinomial, or polynomial by the number of addition and subtraction signs, or positives and negatives, okay? So what we're going to look at next is how to factor a monomial, because being able to do that efficiently will allow us to factor polynomials, which is a little bit more complicated. So we're going to start with the monomial 4x cubed y squared. So when you factor a monomial, you're basically taking each piece of an algebraic term and writing out what that means. So with our coefficient, we're writing out how basically the prime factorization. So how do we make 4? We make it with 2 times 2. Okay. Same idea with your variables. We're breaking it down. So what does x cubed mean? Well, x cubed means x times itself 3 times. So we can write x cubed as x times x times x. And then y squared, right, means y times itself. So we would write out y squared as y times y. So when you factor a monomial, you're essentially writing the prime factorization of your coefficient, the number, right? In this case, it was positive. And then breaking down each exponent, right? What does cubed mean? What does squared mean? So eventually we would get 4x cubed y squared factored is 2 times 2 times x times x times x times y, right? So what are the factors of your monomial, right? What makes up your monomial, okay? So let's look at another one. Let's do negative 6ab cubed c squared. Okay, so be careful here because the negative matters. So what two factors make negative 6? So that's either negative 2 times 3 or negative 3 times 2. Either one's okay. I usually like to attach the negative to the larger factor. So I'm going to say negative 6 is, I'm going to put it in parentheses this time, a negative 3 times a positive 2. Okay, how do we make a? Well, that's just a. How do we make b cubed? That is b times b times b. And then how do we make c squared? That is c times c. So if we've done this correctly, when we multiply this all back together, we should get the original expression. So negative 3 times positive 2 is negative 6. A, right, there's no other a's here, so that's just a to the first, or just a. We've got b times b times b, that's b 3 times, repeatedly multiplied, so we use an exponent of 3, and then c times c gives us c squared, right? So this is the correct factorization of negative 6ab cubed c squared. So factoring a monomial is just breaking it down into its individual parts that make up the original algebraic expression when we multiply it, when we squish it all back together. So let's look at how that's going to help us factor polynomials. All right, so here we have the binomial, right? Two terms, because we've got 6x squared y, which if we want to think about it is positive, and then positive 3xy squared. So how are we going to factor this binomial? So when you factor binomial, you're pulling out everything that they share, and then what's left over we'll deal with here in just a second. So the first thing that you can do to start off with, and you'll get better at this and more efficient with it eventually, is factor each monomial individually. So let's start with 6x squared y. So if we break this down, 6 is 3 times 2. X squared is x times x. And then y is just y. So there is the factorization of 6x squared y. Okay, now let's look at positive 3xy squared. So there's our factorization of the first term. Here's our factorization of the next one. 3 actually is prime already. So 3 factored is just 3 times 1. We don't need to include the 1. So we just write it as 3. X is just x, and then y squared is y times y. So there we've got the factorization of 3xy squared. Now, what we do next is we pull out everything that they share. So we want to find everything that they share. So I see that they share a 3. They share 1x, right? Because there's only 1x and 3xy squared. And then they also share 1y. Again, because there is only 1y and 6xy squared. That's the most that they can share. So we're going to pull out what they share. So they share a 3. They share an x. And they share a y. So we're pulling that out. What we do next is with what is left over, we leave that inside of parentheses and we connect them with the original addition or subtraction sign. So we'll get there in just a second. So when we pulled 3xy out of 6x squared y, we were left with 2x. So we leave that 2x inside. And then this is really important, right? Whatever the addition or subtraction sign that combined them originally needs to come back into your parentheses. So it was a plus up here, so it needs to be a plus up here. And then what was left in our second term? Well, when we pulled out 3xy, right, you can cross these out if that helps to see what's left over. So when we cross, right, our common factor of 3xy, that's what we pulled out. What was left in our second term is just y. So when we factored that, we pulled out everything that they shared, the 3xy. What was left from our first term? Just 2x. What was left from our second term? Just the y. And inside of parentheses, we combine that with our original addition or subtraction sign. So we've got 3xy times what's left over from each equation. So what's outside is what they share. What's inside is what's left over after we divide by that common factor. So 3xy was the common factor. Once we divided that, we were left with 2x from the first term plus y from the second term. So when we factored this, this is our answer. Okay, can be a little tricky, but let's do another one. All right, so for our next one, we've got 8a cubed b squared c minus 4a squared b. So first thing we're going to do is factor both of these. So 8 is 4 times 2 but then we can break down that 4 and say that 4 is 2 times 2. So we could say that 8 is 2 times 2 times 2. A cubed is 3a, so times a times a times a. B squared is b times b, and then c is just c. So there is the factorization of 8a cubed b squared c. Next, we're going to deal with the negative for a squared b, or just minus. So two ways you can do this, right? And I think the easiest way is to just set aside the negative right now. We'll deal with that in a minute. So 4 is 2 times 2. A squared is a times a, and then b is just b. So now what we want to do is figure out what do they share. So I see 3 2's over here, 2 2's over here. So they share 2 of those 2's. They share 2 of those 2's. We've got a squared over here, a cubed over here, so they can share 2 of those a's. So they share an a and an a, right? They share an a and an a, with this a being left over. Okay, then I've got b squared and b, so they share 1 of those b's. And then this one has a c, but this one doesn't, so they don't share a c, so I can't circle that. So what they share is 2 2's, 2 times 2, 2 a's, a times a, and 1 b. So when we put that all together, they share 2 times 2, which is 4. They share, so we can cross those out, a times a, which is a squared, and then they also share 1b. So their greatest common factor is 4a squared b. Now, we're going to put what's left over inside of parentheses. So what's left over from our first term, we have a 2, we have an a b, and a c. Okay, this is where it's important. Last problem, we had an addition sign combining these. Now we have a subtraction sign. So what needs to separate the two terms, what's left over from the two terms, is that subtraction sign. That's important. So that subtraction sign needs to follow us through. And then we look at what's left over. Now, you might think that there's nothing left over. But what we really did is we divided 4a squared b by 4a squared b. When you divide a number by itself, there's actually 1 left over. So we're going to put a 1 here, because when we divide 4a squared b by the greatest common factor, 4a squared b, we don't get nothing, we get 1. And if we don't put that 1 there, then this second term disappears, right? It stops existing. So that 1 is important because it shows us that there is, in fact, a negative 1 of this greatest common factor left over. And then we can actually check that using the distributive property. So distributive property says take what's outside of parentheses and multiply by what's inside. So like, for example, if we had 3 and then in parentheses 6 minus 1, we could distribute the 3. 3 times 6 is 18, and then 3 times 1 is 3. How are they combined? Through subtraction, so 18 minus 3 is 15, right? So we can use the distributive property to check. So if we distribute 4a squared b to 2abc, multiply the numbers. 4 times 2 is 8. A squared times a is a cubed, add the exponents. B times b is b squared, and then times c, c is just left over, so just c. So if we check, 8a cubed b squared c is what we had in the original equation, so far it's looking good. And then we have 4a squared b times 1, which is just 4a squared b, and then combine them with the symbol that's inside, right? So that's minus. So check it. Does this look like our original equation? It does, so we know that we're good to go. All right, one more problem with 3 terms. So we're going to try and factor a trinomial. All All right, for our last example, we're looking at a trinomial. 6d squared e squared f plus 3d squared e minus 2e squared f squared. So we can write that out. 6 is 3 times 2. D squared is d times d. E squared is e times e, and then just times f. So there's our first term. Plus 3 is just 3. D squared is d times d. E is just e. And then minus 2 is already prime, so 2 is just 2. E squared is e times e. F squared is f times f. So now we want to look at what they share. And now they have to share all three terms have to share something, right? So it can't just be two of these terms share, the third one doesn't. For it to be a greatest common factor, it has to be in all three. So if we look here, right, they actually don't share any numbers. So these two share a 3, but this doesn't have a 3. These two share a 2, but this doesn't have a 2. So we actually, right, aren't pulling out any numbers at the moment. What do they share? A little tricky, right? If we're looking here, it really looks like the only thing that they share is an E, right? There's an E here, an E here, and an E here. So if that's all they share, that's all we can pull out. So you pull out that, and then what's left over, right, is what goes inside the parentheses. So we're pulling out an E. What's left over from this first term is 3 times 2, which is 6, d times d, which is d squared, an E and an F. Then we've got this addition sign, so I'm going to say plus. What's left over here? A 3 and a d times a d, which is d squared. Let that addition or subtraction follow you through. Minus what's left over here? A 2, an E, and an F. So not the best example because the greatest common factor of these three things was just the E, right? That's the only thing they really shared. But you could pull out that E, and then what's left over goes inside of parentheses. And again, if we use the distributive property to distribute this to each piece, we would get back to this original equation.